Hello everybody. In this video, we are going to design a problem to understand the mesh analysis using matrices and to solve it. This is problem number 3.42 from Fundamentals of Electric Circuits by Alexander and Sadiku's 5th edition. Okay, let's get started. As we need to design a problem, the voltage source values are not given. Assume some values for this voltage sources. Let me take this values V1 as 30 volts, V2 as 20 volts and V3 as 10 ohms. And we need to find out this I1 current, I2 current and I3 current. So this is 30 volts, this is 20 volts and this is 10 ohms. So as this is mesh analysis, we are going to write the loops. So for loop 1, we apply KVL, Kirchhoff's voltage law. It states that in a closed loop, summation of the voltage source and the voltage drop are equal to 0. So if you consider this loop 1, we start from here and we move on like this, isn't it? So for that we can write the equation as minus 30 volt and then plus. Here you have to assume this as plus to minus. Here also you have to assume this as plus to minus for this I1 current. Okay. So plus 20 I1 plus 30 I1 minus through this 30 ohm resistor I1 current as well as this I2 current are flowing in opposite direction. Okay. So we have to write this I2 current which is flowing through this 30 ohm resistance as the voltage drop minus 30 I2, that is equal to 0. So here we can sum up this I1 currents as 50 I1 minus 30 I2, that is equal to 30. And if you divide this by 10, then we get this as 5 I1 minus 3 I2, that is equal to 3. This is equation number 1. Now we go for the second loop, loop 2. So for which we are again applying the KVL so that it can be written in a one shot. You can write this currents I2 and the I1, I3. Okay. So how many resistors are involved in this loop? 30 plus 30 plus 40. So we can write it as 100. Okay. So 100 I2, it is plus, isn't it? 100 I2. Then what about this I1? It is flowing through this 30 ohm resistance only, but you have to put minus sign for this 30. So 30 I1. Then through this 40 ohm resistor, the I3 current as well as I2 currents are flowing. Okay, so this I3 current is to be included here in this. So it is minus 40 minus 40 I3, that is equal to, when you start coming from here, this I2 current is flowing in this direction, so it has the plus sign. So for this 20 volt resistor, the entering point has minus sign, isn't it? So you have to make it as minus 20, that is equal to 0. So this can be rewritten as minus 30 I1 plus 100 I2 minus 40 I3, that is equal to 20. So this can also be divided by 10. So you get this as minus 3 I1 plus 10 I2 minus 4 I3, that is equal to 2. This is equation number 2. Now we go for this third loop. So for that we can apply this mesh analysis, loop 3, for which we apply the KVL. So it is here, the current will be flowing like this, isn't it, for this loop 3. So for I3 currents, the resistance is 40 plus 10. 50 ohm resistance is involved. Okay, so it can be taken as plus 50 I3. Then this 40 ohm resistance, when you consider this, it is common for both I2 and I3, so you can put it as minus 40 I2. No I1 current is involved, isn't it? But when you travel in this direction regarding this voltage source, it is also here entering, point is having this minus sign, so you can put it as minus 10, that is equal to 0. So it is minus 40 I2 plus 50 I3, that is equal to 10. If you divide this by 10, we get this as minus 4 I2 plus 5 I3, that is equal to 1. So this is equation number 3. So we got 3 equations. So we have got these 3 equations, and now we can write this in matrix form as this is 5 minus 3 0, then minus 3 10 minus 4, then here it is 0 minus 4 and 5. These are the coefficients of the currents, isn't it? Multiplied by this I1, I2 and I3, that is equal to this 3 2 and 1. This is the voltage, so V equal to IR. Okay, in this we can find out this delta, the determinant value of this. So this delta is equal to, so how do you find it out? For this 5 into, then this 10 into 5, so it is 50 minus 4 into 4, 16, then minus, already minus is there, so minus of minus plus 3 into this 3 into 4, it is 12 minus 0, then 0 into these things, so it becomes 0. So delta value is equal to 5 into 34, 50 minus 16 is 34, plus 3 into 12 is 36. So 5 into 34 is equal to 170 plus 36. So that is equal to 206. So the del value is equal to 206. So now we are going to find out this del 1. So in order to find out this del 1, we have to replace this 5 minus 3 0 using this voltage values, that is 3 2 1. Now we can find out this determinant value. 3 into 50 minus 16, 4 into 4, okay, minus of minus 3 plus 3 into, here it is 4 into 2, 8, minus sign is there, so minus 8, then 1 into 10 minus, okay, minus 1 into 10 is 10, then we have the 0, so it is 0. So this is equal to 3 into 34 plus 3 into minus 18, that is equal to 102 minus 54. So this del 1 value is equal to 48. From this we can easily find out this I1 current, isn't it? So this I1 is equal to del 1 divided by del. So this is equal to 48 divided by 206. So this is equal to 0.233. So this I1 value is equal to 0.233 amps. Now we want to find out this del 2. So in order to find out this del 2, the second column should be replaced by the voltage values, that is 3, 2, 1. Okay, so now we find out this determinant value for this matrix. Then it is 5 into 10 minus of minus 4. So we do this, right? Then this 3, that means minus 3 multiplied by, so this 3, there we have to do this, this is 0. Then minus 3 into this 5, isn't it? So it is minus 3 into minus 15. So this is minus 3 into, so leaving this minus 3 into 5, that is minus 15 minus this 0. Okay, 4 into 0 is 0. Then 0 into everything is 0. So we got this. This is equal to 5 into 14 minus of minus plus 45. So this is equal to, so this is 70 plus 45. This is equal to 115. So del 2 is equal to 115. So we can calculate I2 current. I2 current is equal to del 2 divided by del, that's equal to 115 divided by 206. This is equal to 0.556. So this is equal to 0.558. So I2 current is equal to 0.558 amps. So now we are going to find out this del 3. So for del 3 we have to replace this third column by the voltage matrix. So it is 3 to 1. So del 3 is equal to 5 into this 10 minus of minus plus this 8, then this plus minus of minus 3, it is plus 3 from here, multiplied by this 3 into 1 minus 3 into 1, so minus 3, then this is 0, then this 3 into this is plus 12 minus 0. So this is equal to 5 into 18 minus 9 plus 36. So this del 3 is equal to 90 minus 9 plus 36, which is equal to 117. So what is I3? I3 is equal to del 3 divided by del, that is equal to 117 divided by 206. So this is equal to 0.5679. So this I3 is equal to 0.5679 amps. So let's summarize these answers we got. So this I1 is equal to, so the answer is I1 is equal to 0.233 amps, and this I2 is equal to 0.558 amps, and then this I3 is equal to 0.5679 amps. Okay, thank you. Hope you have understood.